superior mesenterics coming from lower parts, and so forth. So, how do sympathetics get to, say, the gallbladder? We'll go over this again. Okay, the preganglionics come here from the T5 to T7. They travel down to the ganglion around the celiac artery. Okay, the postganglion, after they synapse there, the postganglionics will follow the common hepatic artery, and then they'll go up the proper hepatic, and then they'll go into the right hepatic, and they'll follow the little cystic artery out to the gallbladder. The preganglion, the sympathetics going to the sigmoid colon will come from this lower area, go through the inferior, go to the inferior mesenteric ganglion where the preganglionics will synapse. The postganglionics will follow branches of the inferior mesenteric artery until they get to the little sigmoid arteries. They'll follow the little sigmoid arteries out to the sigmoid colon, and there they will innervate the musculature, the smooth muscle in the wall. Yes, sir.
Quick question. So for like say a pathway question on the exam.
Sorry, what kind of question?
For like a pathway question like that on the exam, if are we responsible for like I guess like in the preganglionic part, the first part, are we supposed to put like what level? And if we are, can we just follow the 5-4-3 rule? Because since there is
yes. So anywhere within there, there's obviously a lot of slack in there, so you get a few levels in the origin of preganglionics. Okay, so here are sympathetics to liver and gallbladder. Okay, for the sympathetics, they're coming down with the greater splanchnic nerve, right, going into this celiac ganglion. Okay, and then they're going out with the common hepatic. Then they're following the hepatic proper. Then they're going into the right hepatic, and then they're going through the little cystic artery and to innervate the gallbladder. Parasympathetics are thrown in here. We'll talk about them a little more in a minute, but real parasympathetics are a lot easier in that everything from the foregut and midgut gets its parasympathetics from our old friend, the vagus nerve. Right? That's been vagus nerve all the way down, and it continues to be vagus nerve most of the way through the abdomen. The vagus nerve, when it came into the esophagus, in the upper part of the thorax, there was a right vagus, and then there was a left vagus. Remember, you saw the left vagus sending a recurrent laryngeal under the arch of the aorta, and then the rest of the vagus got to the esophagus, where it split all up into this esophageal plexus. Right and left mixed it up a bit. That's what plexuses are all about. And what came out was an anterior and a posterior vagal trunk. Okay? So part of this posterior vagal trunk comes down, goes into the celiac ganglion and plexus. Doesn't go into the ganglion, the celiac plexus. So this plexus is a mix of the sympathetics that are coming down here and synapsing and the parasympathetics, which are coming down here and not synapsing. Right? So the parasympathetics are going to go into this mess of stuff around the celiac artery. They're going to go into the plexus. They're going to come out with the postganglionic sympathetics, follow this bloodstream all the way down, right? Go into the common hepatic, the hepatic proper, the right hepatic, the cystic artery, go into the gallbladder, and in the wall of the gallbladder, they're going to synapse, and the postganglionics will just appear there in the gallbladder itself. So the preganglionics are following the same path as the postganglionic sympathetics to get to their abdominal visceral structure. Okay, so let's go back and look at these parasympathetics again, which are immensely simpler. Okay, the parasympathetics to the abdominal body wall. So remember, you got sympathetics going to the abdominal wall to make these muscles, make the hair on your back stand up, and to contract the smooth muscle in the blood vessels, and to make sweat glands sweat. And in the body wall, there are no parasympathetics. You don't have to turn off the smooth muscle. If you stop sending sympathetics, it relaxes. You don't have to turn off the muscles that raise the hair on your back. If you stop the sympathetics, they lie down without being told to, unlike my dog. And same with the glands. So there are no parasympathetics to the body wall of the abdomen. See, there's something easy about this. Okay, parasympathetics to abdominal and pelvic viscera. Well, it's the same story as the parasympathetics we've talked about before. There are two sources of preganglionic parasympathetics. The brain, in this case the vagus nerve, and down here in the sacral region. And for most of the abdomen, the structures we've seen, we're talking about vagus, just as they show. So the vagus comes down, splits into anterior and posterior vagal trunks. They go into these plexuses and follow the sympathetics, which are following the blood supply to the organs of the foregut and the midgut. In the organ wall, they synapse. The pelvic splanchnic nerves, the other source, right? For our purposes, there's brain and sacral. The sacral stuff comes out of the S3 and 4. They travel directly to the organ walls. They don't go through anybody else. Okay? And that's how the parasympathetics to the hindgut and pelvic structures, which we don't see. Postganglionic parasympathetics, just like in the abdomen, just like postganglionics in the thorax, they are in the organ walls. You do not see them. In the pelvis, it's little stuff going on, but we don't really have to worry about that. So the postganglionic the synapse is in the body wall, and the postganglionic axons don't really have very far to go because they're already there. Okay. I know this is tedious and repetitive, but that's what it takes. Yes?
Just to make sure the parasympathetics that are going to the hindgut are not going to go through the celiac plexus.
No, the hindgut blood supply is coming from the inferior mesenteric artery, right? And the midgut blood supply is coming from the superior mesenteric artery. So the parasympathetics to the midgut are following the sympathetics, are going with the sympathetics from the superior mesenteric artery. The ones to the hindgut, the ones to the hindgut are not getting there from the vagus. They're getting there from somewhere else. That's what we're talking about right now. So the vagus, all preganglionics comes down and sends, branches to this stuff in the thorax, the hearts and lungs, and then it comes down and follows the sympathetics from these ganglia around the celiac trunk to go to the stomach and first part of the duodenum, and then other vagus preganglionics go down to the superior mesenteric artery, where they join up with postganglionics and follow the superior mesenteric artery out to most of the small intestine, the cecum, the ascending colon, and most of the transverse colon. There, the vagus gives up. It says, look, I've come from the brain. I'm virtually all the way down in your abdomen. Give me a break, And so it quits. So there are these other preganglionic parasympathetics coming from S2, 3, 4, out of the sacral region, coming out of the sacrum, going into the inferior mesenteric artery, and following its blood supply, following the sympathetics and basically the blood supply from the inferior mesenteric to the descending sigmoid colon and upper part of the rectum. So it's vagus all the way down to about right here. We generally say that pubic flexure. And it's these pelvic splanchnics are the source of parasympathetics down here. And we're always talking about preganglionics, because the postganglionics are hiding in the body wall. Yes?
Does the anterior and posterior vagal trunks go to the celiac trunk plexus, or Or is it just the
I
posterior?
am not sure how the difference between anterior and posterior trunks. For our purposes, we don't need to worry about that. Okay, so here we are again, in case you missed it the last time. So right and left vagus, remember here's a left recurrent laryngeal, the right recurrent's going to be up there. Coming down here into anterior and posterior trunks, and then zipping down to these ganglia. Parasympathetics to abdominal viscera. Okay. Okay, mostly come down from vagus. However, lower down, the lower abdomen and pelvic viscera are getting their preganglionics from S234. They're coming from the same place that at higher levels, right? That's where the sympathetic preganglionics came from. So these parasympathetic preganglionics down below where any, sympathetic stop right in the upper part of the lumbar region. In the sacral region, you've got parasympathetic preganglionics coming from roughly the same area, going out with the ventral root, going into the spinal nerve, and then zipping out either to pelvic organs or to tiny little ganglia that are around them. But we don't see that, and you can't see them, and we don't dissect them anyway. Okay, so same story, right? So you got the preganglionic parasympathetics coming out, avoiding sympathetic ganglia, going into body wall, synapsing in body wall, unlike sympathetics which are synapsing somewhere else. So, again, visceral motor, same story I saw before. We trace the sympathetics down here. Parasympathetics are coming down with the vagus, going into this plexus. So when you, like I say, you go down to the celiac trunk or superior mesenteric artery, and it's all this fibrous stuff wrapping around them. That is the plexus, consisting of preganglionic parasympathetics and mostly postganglionic sympathetics that are going to follow the blood supply and go to do their stuff on the organs. Down lower, the other source of preganglionic parasympathetics, right, is coming out of S234. They're coming down here, mixing it up, okay, with the sympathetics, right, that have come from upper lumbar and thoracic region, and the postganglionic sympathetics and preganglionic parasympathetics are going to go off to do this lower part of the digestive tract, the descending colon, sigmoid, and upper part of rectum. Okay, more of the same. Splanchnics coming down, greater splanchnic, lesser, least, going down to celiac trunk and superior mesenteric, and then traveling out to all of these areas. Way down here, you've got this stuff from the lower stuff going up into there. It's just a summary, yes.
For the pelvic and genital innervation, is it variable?
The pelvic what?
And genital innervation of the parasympathetics, is it variable between S2 and 3 and 3 and 4?
I do not know.
Because here it shows S2 through 4, and on the dermatome maps it shows S2 through 3, but in the previous slides we were saying S3 and 4.
Yeah, if you go to textbooks on this, the textbooks usually say 3 and 4, and then some will say 2 and 3, and then people will be 2 in parentheses.
Right.
And now 2 seems to be gaining strength, so some texts now say 2 and 3. So it's probably very variable down there, just as numbers of vertebrae change a little bit here and there.
Right.
But no, they're coming out of the sacral region. That's the bottom line, and they're not coming from the vagus. Okay, what is all this visceral motor good for? The same stuff we talked about in the thorax, right? Sympathetic is fight or flight. It means let's get out of here as fast as we can. Parasympathetics is let's hang out and have dinner. Okay, and build up our energy. So, in the foregut and midgut, sympathetics are going to decrease peristalsis, decrease secretion, decrease blood flow. You don't want to waste your blood digesting your dinner. You want to get it to those muscles so you can run away from the lion. In the hindgut, it's the same story. Decreases peristalsis. We don't want to process any food through our gut. We just want to get out of here. Urinary tract, it slows down making urine and contracts your bladder. The suprarenal glands, it sends adrenaline. So what do you want sympathetics to do? Give you lots of energy, more than you would have to let you run away. And that's adrenaline's coursing through your veins, and you suddenly can run fast, not get bitten by the lion. Parasympathetics, they're doing the reverse. They're going to increase peristalsis. Let's move that fluid through. They're going to increase secretion. Let's throw some bile in there to digest those fats, and throw some other stuff in there to make sure we get lots of energy out of this food, increase blood flow to the gut structures so that they can suck up all those nutrients and send them off to the liver to be passed on to the body. In the hindgut, again, let's just move stuff through. Let's get all that stuff we've already sucked all the energy out of and poop it away. And the urinary tract, yeah, we might as well just, pee and get rid of all that water so that we can get some more in. And they have no effect on the suprarenal glands. Suprarenal glands, you don't want to use adrenaline. You just want to calm down and digest. Yes?
How do the nerves get to the kidneys and the suprarenal glands? Do they go through like any of these plexuses that we're talking about, or do they go through?
That's another story. And you'll blessedly not look at it. It's a mess. A suprarenal gland is really very complicated. There's all sorts of layers of stuff. I can send you slides and lectures on it if you want. Trust me. Okay, what about there is another part, right? There is visceral sensory, right? That sort of dull stuff. Oh, I've got a bellyache. Oh, my gallbladder hurts. I shouldn't have, eaten that plate of spaghetti. 3 boxes of potato chips or whatever. Okay, what do we know about visceral sensory? Okay, it's a 1 neuron system. It doesn't have to worry about synapses along the way, and it follows the sympathetics. Okay, so this is going to be sort of weird, isn't it? Because our origin of sympathetics, where does sympathetics come from? Preganglionics. Don't all speak at once.
Wait, is it the T7? Is it the T7?
T1 through L2, preganglionics, or T1 through L2.
So
Okay.
what would you
But right, abdominal
Because it's-
preganglionics are a little
okay.
bit lower. But the point is,